Good evening, everybody. Can you hear me?
Yes, sir.
Yes, sir.
Okay. So far, we discussed Docker or container management commands. Today, let's discuss something called Docker images. Say, 1 second. Till Maven, this is what we have done, right? So this is how we built our code, application code, and then deployed the code into Tomcat server, right? Say, commit the code, clone the code, build the code, and then we deployed the var file in Tomcat server. Tomcat server. And then anybody can access the application using load balancer. Flipkart.com. Fine, you know this. So 3 steps here: clone, build, and then deployment. So I would say this is, a traditional old deployment model. This is not the the latest and greatest automation. If you see here, we build the code using Maven. Okay, we create the var file, right? And then we deploy this particular var file into Tomcat server. That's what we have done. And before you deploy, before you copy this particular var file into Tomcat server, before you copy the var file into Tomcat server, you should have few things already here, right? What's that? You should have Tomcat server installation. And for Tomcat, you should have a JDK, correct? And if you take real time, you may need some database, you may need blah, 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 and so on, correct? Right? So this is your code, right? To run this particular code, you need some dependencies, correct? You need some prerequisites. Remember these two words. You need some prerequisites. You need some dependencies. So if you want to execute the code and then serve that as an application, you should have Tomcat, JDK, blah, 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 Nginx, database, blah, 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 and so on. And before you deploy your var file into Tomcat server, right, into this mission, you should have all this installation ready. How much time it took for you to, how much time it took for you to build and deploy the code, correct? Very sorry. How much time it took for you to install Tomcat, JDK, and then deploy your code? It takes more time, right? With Docker, if you have Docker in your project, this is how we deploy the application. So without Docker, what you're doing, you are just creating the var file, and then before you deploy the var file, you install Tomcat, JDK, all prerequisites and dependencies, and then you deploy your code here. That's a traditional deployment model. Let's see what happens with Docker. If you have Docker, you know what we do? We first clone the code, then we build the application as usual. Second step, using Maven, we create the var file, correct? This is your code, compiled code. And as a third step, here we create something called image. We create image here. So this is your image, okay? This is your image. And in this image, we bundle code and then prerequisites. Assume that this is my code, correct? To run my code, to run this particular code, I need say Ubuntu OS. I need Ubuntu. So I'll bundle Ubuntu here. Okay, this is your image. Name of this image is, for example, whatever, gamut cart application image, say for example, gamut cart image. So how you create the image, we'll talk about that later. You first clone the code, you build the code, and then if you are using Docker in your project, right? So if you are using Docker technology in our project, this is the automation improvement that you are going to see. So we'll get the image, right? So in the image, I have Ubuntu OS, and then I'll bundle everything, whatever I want to execute this particular code. Think image as a zip file. Think this image as a zip file. Inside the zip, you have files and folders, right? Inside image also you can bundle a lot of things. We don't call it as a zip, it's an image. So you have Ubuntu, and for my gamut cut application, to run this particular code, what I need? I want JDK, right? I'll place JDK in this particular image. I'll place Tomcat also in this image. And then I have the code in the image. And then I will also bundle a command, okay, command, which will start Tomcat server, So inside the image, what I have code plus prerequisites dependencies. Image contains application code plus prerequisites dependencies, which are required to run that code. We'll create the image. And from this image, you can create a container. We always create a container from the image, correct? If you create a container means a mission from the image, what you will get in this container? Whatever you have in the image, same thing comes in the container. Whatever you have in the image, same thing comes in the container. What is there in the image? In the image, I have Ubuntu. So I'll get a Ubuntu container. Inside the container, right? Ubuntu container, I already, I get JDK by default. I also get Tomcat automatically. I also get this particular code automatically inside the Tomcat. And then there's a command to start Tomcat server, right? So this command will be executed, and then Tomcat server is also running. This is what I need. Correct. So earlier, what we used to do, we used to build only the WAR file, and then we used to take a virtual machine, for example. We used to install, JDK, Tomcat, and then we used to deploy the WAR file, and then we used to start Tomcat server. Are you doing all these things now? No. So what we're doing here, once the application is built, we are bundling the code along with its dependencies or prerequisites. And then from this particular image, we are going to create the container. If you create a container for this image, what will happen? Whatever you have in the image, same thing comes in the container. So in this case, so I have a container, and remember, this container is created within less than 1 second. See this, see the miracle here. Within less than a second, right? You are able to create a mission, right? Which has your code plus dependencies or prerequisites within less than 1 second. See how quickly you are able to create a server for your application. We call this as application containerization. What do you call this? Application containerization. Meaning you are running your application in containers. What is application containerization? Running application in containers is called as application containerization. So if you want to run, this is a container, right? If you want to run your application inside the container, if you want to run your application in containers, what you have to do? You have to create the image. Okay. What you have to do if you want to containerize your application? Containerizing the application means running application in containers. If you want to run application in containers, if you want to achieve containerization, you have to create the image. So this is called as custom image. This is my own image. This is not Ubuntu. Okay, I am taking Ubuntu image. On top of Ubuntu, I am adding something extra. Okay. So we call this as what? Application containerization. If you want to containerize your application, you have to create the image. And from that image, you can get any number of containers. What is the difference between
1 minute, so we can say container is a replica of image, right?
yes? That's what I was going to and you stopped me. Okay, good.
Okay. So what images contains everything container also it will having, right?
And I'm explaining that only. So just give me
okay.
one
Okay,
second.
go on.
Yeah. So image and then container, right? This is your Ubuntu image. This is your Ubuntu image. Ubuntu image. From image, you are getting a container, correct? This is Ubuntu image. This is called as a base image. Because that's a official Ubuntu image, right? From the Ubuntu image, you are going to create a container. Remember, we always create container from image. Okay, without image, you cannot create the container. From Ubuntu image, we are going to create the container. This is our own image, correct? This is our own custom image. What I have done in this image, I have taken Ubuntu image, same thing, the base one, and then I place JDK inside this, bundled JDK in this my image, and then Tomcat in my image, and then I have placed some code, that var file, and then I have placed a command which starts the Tomcat server. So this is my own image. And from the image, you can get a container, correct? We also create the, we always create the container from the image, right? So if you create a container from Ubuntu image, you will get Ubuntu. You will get plain a container which has Ubuntu operating system. It just has Ubuntu operating system. That's all. If you create the container from my image, I'll get Ubuntu operating system plus JDK plus Tomcat installation by default plus my code plus Tomcat server is running. So this is what happens if I create a container from my image. Image, container, both are same. Image and container, both are same, correct? Image, container, both are same. Only the difference is what? Image is static. Image is static. Container is its running instance. Container is its running instance or running entity. Running instance. This is static, this is running. Correct. This is like a zip file, right? I told you it's like a zip file. It's like you have a zip. Inside the zip, you have Ubuntu OS related programs utilities. Inside this particular image, you have inside this zip, you have JDK, you have Tomcat, you have code, you have a command in that zip file, which will start Tomcat server. It's a zip. It's a static. Things are not running there. But this one, right? The moment you create a container from this image, what will happen? Things come in play, right? Now your Ubuntu operating system is running, JDK is running, Tomcat is running, you have the code in this. It is like mission. It's a mission, right? It's like a computer, and then you have things running there. So image is static, and container is its running instance. So that is the only difference. Image, container, both are same. Only the difference is what? Image is static, things are not running. In container, things are running. So you can create a container from the image. So what we are going to do here, because we don't want to manually install everything, right? So this is one container, right? Likewise, I can create hundreds of containers, correct? So what I'm going to do, what I'm doing here, I'm cloning the code, compiling the code, and I know what is required for me to run, what is required to run this particular code. So what is required to run the code? When you join the project, you will come to know. Okay? Somebody will tell you, development teams or development teams usually will tell you what things are required to run this particular code. In my Gamut cart application, I need JDK, Tomcat, blah, 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 blah. If you need, say 20 things, bundle 20 things in the image. And from the image, you create a container. So whatever you have in the image, same thing comes in the container, right? And you are not, manually installing anything here. Within less than a second, you are able to create your application instance. For example, assume that this is a Flipkart project. So If I want to create a Flipkart instance, Flipkart server, I can do this. And so this is one advantage, right? See the advantage of image. And we have other advantages also, right? What are the other advantages? Container is lightweight, right? You can create container very quickly. It's lightweight. You can start it very quickly. You can stop it very quickly. And today's advantage, you can create application instance, right, within less than a second, which has code plus all your dependencies. That is image concept. Now you see, having Docker in your application, Docker technology in your application without Docker, which one is better? If you have a Docker, see that one is correct. So you get all these advantages. That is the reason these days applications are moving to containerization. Applications are moving to containers. Companies are trying to run their application in containers, not in virtual machines. So likewise, you can get any number of containers. I'm talking about only one container. So assume that I want, say, 100 containers. What do I do? From this image, you can, if you have an image, you can get any number of containers from the image, right? If you have this image, you can get millions of containers. Assume that it's a Flipkart, and then I want, it's a production. I want 100 machines. This is the load balancer. What do? Container 1, container 2, container 3, and so on. You can create 100 containers. This is container 1, right? Container 2, container means a mission, right? Container 3 and container 100. And how you are getting 100 containers? From this image only. Docker run -it image name. That's how you create the container, okay? Docker run -it. Earlier, we created plain Ubuntu container, right? Now we are getting the container from our image, Docker run -it. If you run this command, Docker run -it, instead of Ubuntu, you just give our image, gavat cart -image, this one. So this will create a container. And what you will get in this container? What will be in the container? So if you create a container from this image, you have JDK, Tomcat, your application code, and then Tomcat server is running. Same thing here. You have JDK, Tomcat, code, application is running, JDK, Tomcat. See? So you are able to create 100 containers now within less than few seconds. How quickly you are able to create this? Earlier, if there is no Docker, we have, in traditional deployment model, what we do? We have the var file, and then so we have to take a mission. We have to install JDK, Tomcat, and then deploy the var file. Again, take another mission, install JDK, Tomcat. See here, we only JDK, Tomcat, but in real time, you may need to have say 10, 20 things, right? So you have to install everything. Now you're not installing. I just create a container. Everything comes out of box. Within less than few seconds, I can get any number of containers. And then my application is ready. So we call this as what? Application containerization. If you are running your application containers, we call it as my application is containerized. Is your application containerized? Means what? You are able to run your application in containers. Is your application containerized? Means what? You have created the image. You have your own custom image, and then you are able to run your application in containers. Application containerization. Clear this? Understand the importance of Docker image, the value addition that it is bringing to DevOps automation. Any questions you have?
Yeah, I do have. Suppose we have one application server and it's running fine, then why do we require this containerization?
Because of all these advantages, right? See, if you don't have containerization, what happened? Tell me. If you don't, assume that you are not using Docker, you don't have containers. As I said, we create the var file, right, Ashish?
Yeah.
Right? And then you have to deploy the code in some server, right? So you have to install JDK, Tomcat, everything here, no?
Yes.
Right? So you have to install JDK, Tomcat, everything here. And say, for example, you want to, it's a big billion day. You want to, add more and more servers. You want to add 50 servers. What do you have to do? You have to again take a virtual machine, you have to install everything and then deploy the code. So likewise, if I want to add 50 servers, then I have to install all these things, again and again, and then deploy the code, right? That takes more time, first thing. Here, if it is a container, if you have the image, just run docker run -it image name. You'll have maybe 50, 60 containers. Within less than few seconds, you are able to create, you're able to add 50, 60, extra machines to, you can scale up the environment to handle the load. So more load, more missions you want, right? So scale ups, happens very quickly, first thing. And then we are running the applications in the containers, right? So containers don't have operating system. So containers are lightweight. Using, with less hardware, you can, run our application. It consumes very less hardware. And start, stop is very easy. So because of all these advantages, we run application in containers now, not in virtual machines. We try to run applications in containers.
Okay, so like it's based on requirements. Suppose if you want more than one application server, then containerization comes into play.
Yes. Say for example, if you have you have an application, right? Assume that your application, your production environment has only say 5 servers. 5 servers is enough for you. Then you don't need containerization because it's a small application. 5 servers are enough for you. But if you go to Flipkart, you'll be having almost 500, 600 servers in their production, and you have to scale up, scale down, a lot of things because it's a large scale enterprise application. So their containers are helpful for us. Ashish?
Yeah, got it.
So, sir, like how is this scaling up and scaling down happens in a container? Like, do we have some kind of other tools to manage this?
Kubernetes can help us with that.
Okay, sir.
In Kubernetes, we can do.
Okay,
I'll show that you there.
sure.
Okay.
I have one clarification.
Yes, sir.
One. You are telling container is the replica of image. If I want to add some servers
Mm-hmm.
like Tomcat, I want to add some database servers, something. Where I need to add in container or image?
In the image.
First, we need to add in the image. After that, it will come automatically in container, right?
Perfect. Yeah. So for example, today I have only JDK Tomcat, right?
Hmm.
Assume that I want Nginx server also. So I need to bundle that in the image. So I have to, change the image content. And when I create a containers from that image, things will come automatically.
But here, one container, it will go. If it is 100 containers, means how we can identify?
You have to
if-
recreate all these containers. Say, assume that you have 100 containers with the JDK Tomcat. Okay. So I want Nginx. So I will add Nginx, say, for example, here. Okay. So once I add Nginx, what I'll have to do? I'll again destroy all this and then create new containers. Again, you cannot just go and destroy all containers, right, at once, because it's a production, correct? So that's where zero downtime release comes into picture. That means without bringing environment down, you should be able to roll out the new changes. So how do you do that? There are different strategies for that: blue-green deployment, rolling updates, and things like that. So for example, I have some change, right? I need to bring this change in all these 100 containers. You know what? One way, So you first take 2 containers down. Okay. Create 2 new containers from new image. Again, bring 5 down, create 5. 5 down, create 5. So slowly, you destroy the old one and then create a new one. So you are not, maybe there may be a small impact, okay, delay in serving the application, but your application is not completely down. So that's how we, bring the change to the production. Kubernetes will help us with all these things. We'll discuss this in Kubernetes. Aruna, questions?
Yeah, I got it.
So next, okay. Where do we have images? Just for your information, see this. How do you install the images? Docker images. So I have Ubuntu, okay, and then it is the latest. And remember, we store the images in something called Docker Hub. Where do you store the images? Docker Hub. So here, so we create the image, okay. Once the image is created, try to understand the process, okay. We'll be practically executing all these things. So first step is clone. We build the application, we create the image. Third step. This is the image. Once image is created, then we store the image in something called Docker Hub. Okay. We have to push that image to the Docker Hub. There is something called Docker Hub here. What is there in the Docker Hub? In Docker Hub, you have Ubuntu, CentOS kind of free images, right? We can also store our images in Docker Hub. So we have to push that image to the Docker Hub. So here I have my application image, gabat-cart-image. This is my own image. Docker Hub contains now free images plus custom images. Official images plus custom. Why we are pushing the image to the Docker Hub? See, you are creating this image in your laptop, right? So you have to place it somewhere, right? In some, a place where anybody can go and then pull that image, take that image, correct? So who creates the image? DevOps engineer. So once you create the image, we push that image to the Docker Hub. And then we pull that image from the Docker Hub. And you can create any number of containers you want. Say I want 100 containers, so I'll create 100 containers. Assume that I create one container one. So tell me if I create this container one from this image, what will happen? I get JDK, Tomcat, I get Ubuntu OS, JDK, Tomcat, and my var file is already there automatically, and then Tomcat server is running. So likewise, you have 100 containers where you have your code plus dependencies or prerequisites. That's the flow. Push the image, and fifth step, create the environment, production environment or test environment, whatever. How many ever you want, you can create those environments. And I'm able to create environment with 100 containers within less than few seconds, and all these advantages. So this is the workflow. If you are using Docker, if your application is containerized, as a DevOps engineer, this is what you do. Clear? And whose responsibility it is creating the image? It's a DevOps engineer. Clear the workflow? First to fifth steps. You have to remember this. Otherwise, you cannot ask. You cannot answer interview questions. Somebody will ask you.
So-
Okay, 1 second. Can you?
Suppose if you have a plain like simple application server, so for creating an image also, so Docker should be installed over there, right?
Come again, Rajesh.
Suppose we have a application server and we want to create an image for that server. So Docker is required for that, right?
Yes. But we are creating image in one machine and deploying that image in deploying the image in containers. Correct? See. 1 second. This guy is DevOps, correct? This is DevOps in his laptop. Think that way. No confusion. So this is DevOps in his laptop, where the clone is happening, where we're building the code, and where we are creating the image in DevOps in this mission. So here we are creating the image, right? In this mission. So here in DevOps in this mission, Docker should be there. We should have Docker installed in DevOps in his laptop here. That's all. Once the image is built, then don't worry about that mission. Then we push that image to the Docker app and then we pull the image, and then here we create the containers. Here you have your application server, and your application server is, for example, Tomcat is already in the image. So when you create the container from that image, right, you'll get your application server running here, because inside the image application server is installed, and then you have application server running here. So here Docker is not required, right? Wherever you're getting the image, in that machine, you should have Docker installed.
Okay, so like my question is like, suppose there is a test application server and we want to like create an image. So in that test application server for DevOps, suppose he is a DevOps engineer, so we can replicate from that test application server and install Docker and then create an image, something like that.
Sorry.
So suppose I'm a DevOps engineer and I'm having a test application server.
One second. Git, we build the code. Assume that this is your environment, correct?
Yeah. Yes.
You're calling this as test environment, test server.
Yeah.
That means there is no Docker here. In your case, is this a VM or what it is?
Yes, it's a VM.
It's a VM. 1 second. Tomcat server. So we have deployed the var file. There is no Docker so far. Okay. This is your test server. Okay, fine.
So like suppose if I need a image of this Tomcat server, so I have to replicate first this Tomcat server.
Correct. If you need a replica, then you replicate it and then you create another VM. So you get the same thing. Okay. This is what we do.
And now in this Tomcat server, I need to install Docker to create an image so that I can get a containerization.
No. You're mixing virtualization and then containerization now. So in virtualization technology, okay, I had not worked there. This is what happens. Okay. You have a VM, say, for example, right? There are some ways to create an image from this VM, correct? You have a VM. From this VM, you create the image, correct, Ashish? Correct if I'm wrong. If somebody has knowledge in virtualization.
Like for virtual, like creating a like VM. So what we do, suppose there is a server, we take a backup like XVA file, and then from that XVA we create another VM.
Image.
Yes.
What is that? XVA.
XVA file.
Think that as an image file, correct? That's image file, right?
Yes,
So
yes.
you have a VM, right? You create this XVA, correct?
Yes.
Think it as a image. From this image, you can get any number of virtual machines, correct?
Yes.
This is virtualization technology.
Okay.
And you are running the application in virtual machine, correct here?
Yes.
But we try to run application in containers, right? These days. Why? Containers are lightweight, containers take less hardware. And how much time it will take based on your experience if you want to create this VM?
It will take like 20 minutes.
20 minutes. Serious. So it will take more time to create a new VM, correct? It will take more time to create a new VM. If you want to start the VM, it will take more time, right, Ashish? Because you have a full operating system, no? You have to wait for the operating system to come up. You have to start the image more, correct? And it is a virtual machine, right? You have 5 GB operating system installation. So it is heavy. These are the disadvantages of virtual machine, right? Now, in Docker, what we are doing? We are not bringing virtualization technology. You have a VM, you are getting that XVA file, and then from that, think it as the image. Virtualization, in virtualization also you have image. From this image, you are getting any replicas you can get. In Docker, what you are doing? This is what we do in Docker. So we take a mission. We clone the code. We build the application. So here we are not replicating, we're not creating replicas from a container. Here we are creating the image. In case of virtualization technology, you take a test machine and then you are getting image, right, Ashish?
Yes.
Here, once the code is cloned and then built, we are creating the image. This image is not created from another mission. No, we write the code. We write some piece of code to create this image. For example, I write some code, okay? If I execute that Flutter file, in the code I mentioned, I want Ubuntu, I want JDK, Tomcat, blah, 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 blah. I'll show that code to you. So if I execute the code, it will create the image for me. Now, if you have the image, like in virtualization technology, you can create any number of missions, right? So from this image, I can create hundreds of containers. So this image is not coming from any other, not created from any other container or virtual machine. No. So by using the code, we create this image.
Okay. So there is no need of creating another VM.
No. So we create the image using some code, and then we create the container. And you see these are the disadvantages, right? All these disadvantages are fixed here. You can create very quickly. You said 28 minutes close to. Here it is less than 1 second. Less hardware, stop time, is very less and so on. So all these advantages you get.
So can we say Docker as a automation tool for creating image?
Automation tool for creating the, yeah, you can say that. We call it containerization tool because using Docker, we can containerize the application. That means we can create the image and then we can run the application in the containers. Containerization tool. Containerization automation tool. Okay. You can call it the automation tool. Yeah. Ashish, any follow-up question or you got the clarity on that?
Yeah, I understood, but still I have one doubt. Suppose in this case, do we require Docker to be installed on that particular server,
In which server? Which server?
which I need to create an image?
Yes, using Docker only we create the image. Here we have to install Docker. Using Docker only, I told you we write the code, right? We write some piece of
Yes.
code, correct?
Yes.
So using Docker only, we create the image. So Docker should be there.
Okay, understood.
Okay. Now if I tell this, you'll get confused maybe probably. So I told you that we write the code we write some code and create the image, right, Ashish?
Yes.
Correct.
Yes.
Like in virtualization, if we have a container already, we can also create the image. That is also possible here. So in virtualization technology, you have a VM, right, Ashish? From
Yes.
VM, you are creating the image, right?
Yes, correct.
In here also, if you have a container, you can create the image. If you have a container, it's some existing container, you can create the image. And from this image, you can create millions of replicas. This is like your VM virtualization style, correct? This is also possible here. This is also possible, but we don't prefer that because that's a manual way. You will understand that. I'm going to explain that to you now. This is also possible, Ashish. So you have a container. From VM, you create the image, right? From exe file, you create millions of VMs. From container, you can create the image. From that image, you can create millions of containers. That's also possible, but we don't follow that. We don't, use this method in containerization. But this is also possible here, but we don't use it.
So
Okay.
one more question. Now we are creating containers on this VM. From where they are taking the hardware specifications, means RAM or CPU, directly from the Windows operating system or from the virtual machine that we have given to them?
I told you we run all these containers on the cluster, correct?
Yes.
Arjun, you have 100 containers. You need 100 containers. Where we run all these 100 containers? On some cluster, correct?
Yes.
This is your cluster. Here we have the nodes. Remember, node 1, node 2, node 3, node 4. Arjun, that you have 5 nodes. These 5 nodes are attached together. So 5 nodes have each node has 8 GB RAM, 100 8 GB RAM and then octa-core CPU, for example. So these containers are created on these containers are running on 5 nodes.
No, sir. Now, for practicing, we are creating VM containers, 2-3 containers.
One second. So right now, okay.
We
I'm
are
not, once again, right
yes.
now, I'm not creating the containers on cluster like this, like in real time. No.
Yes.
What we are doing, I'm taking only think that there is no cluster. Okay.
Yes.
I have only one mission. That is my Linux VM. Okay. So I'm
Yes.
creating all these containers on one mission only. But in real time, you'll be having multiple VMs forming as a cluster, which forms a cluster, and then we run. But here, for practice purpose, I'm creating the containers on top of only one VM. I'm creating 10 containers or 100 containers on top of in only one virtual machine. Let's understand the concept, then we'll go to the cluster. Question, Lovely.
Yes, sir. For example, I have given 2 GB to my VM for Linux.
Yeah.
Uh,
This is your Linux, personal
Yes.
Linux, for example, okay?
But my computer have 8 GB.
Your,
Windows operating
your
system
machine is VM is 2 GB, your Windows
Yes.
has
8 GB.
okay.
Now, if I create 2 containers, it will
Mhm.
share memory from 2 GB or from direct from 8 GB Windows machine,
You are creating containers on Linux machine or Windows machine?
Linux machine
And
in VM.
Linux machine has 2 GB. Can Linux, when you allocate 2 GB to your Linux machine, can it take
Yes.
more from your Windows? No,
Yes, yes, sir.
no. So you have created the Linux machine, right?
Yes, sir.
You have, at the time of creating, you have allocated 2 GB, right?
Yes, sir.
Now it will take only 2 GB. It will not take more than 2 GB from your Windows. So your VM has 2 GB only. So all your containers use 2 GB only. It will not take from Windows.
That means Docker will see only 2 GB here.
Yeah,
Okay.
because VM is a separate machine.
Okay.
Fine.
So, sir, like when we are running the applications on VM, so we'll have regular patch updates and all, right? So when we are running our application on a container, so how we are doing these patch updates? Like, do we have to do patch install? I mean, like in patch installations in each containers, or like how we just need to install the patches in Node only? How is it?
Two things you're missing here. Okay, so you're talking about the patching in container or patching in host VM?
Yeah, exactly.
Both?
No, I mean like when we are running the application in a VM setup, and
Okay.
we used to have like regular patch updates, right?
We do patch updates, correct? So we have
Yeah.
just to make others understand, you have a Linux machine, okay? Let's say Ubuntu operating system. We are running the application, and then as and when we get OS updates and things like that, or when there is some issue, we install patches in the OS. Okay. Yes. Okay. Next, Vishnu.
So like let's say we are having host machine as Ubuntu, and we have lots of containers in it.
One second.
And for patch,
one second. So we have VM, correct? This is VM.
Yeah.
Right. This is your host, Linux VM. Linux VM. Linux, say Ubuntu, for example, Ubuntu Linux. Okay.
Yeah.
This is your Ubuntu Linux. On top of Ubuntu Linux, you are running everybody 100 containers. Okay.
So for doing patch updates, like do we only need to install the patch update on the VM host node, or do we have to do the patch update in all the containers, which is inside the host?
No, only the VM we have to do. Okay. Now this is a container, right, Vishnu?
Yes.
How is this container created? From this image, correct?
Yes.
How the operating system is coming in this container?
From the host.
This is the Ubuntu, right? Ubuntu image is part of our image, correct?
Yes.
So this container is getting OS from the Ubuntu, not from host, correct?
Okay.
Host is from host. What is coming? Kernel, correct?
Yes, sir.
From host it will take the kernel. So if you install any patch here, so right, your install patch means mostly you change the code in the kernel, right? So that automatically comes here, correct? And
okay, sir.
If and this is okay, this is coming. This has the Ubuntu programs, utilities, and then commands, for example. So if you want to install patch, you have to install only the VM, not in the container. because container is taking the operating system from the host only. Right, Vishnu?
Yes, sir. Thank you.
No problem. That's a good question.
What is
Lot
patch?
of questions.
Even I heard what is patch.
The patch means a small update.
Okay.
Say, for example, Vishnu, did you work on that data patching? Say, for
Yes,
example, you
sir.
have, okay, tell me the recent patch that you have installed.
I mean, like that was in my last organization, sir.
Okay.
So, yeah.
Say, for example, Anna, you have one mission, right? Ubuntu operating system, say, for example, right? So it is, okay, 20.04, for example. In 20.04, there was some issue, right? Somebody reported some issue saying, okay, something is not working in the operating system. Then in that case, they will give you the patch. Patch means some code, zip file, or it can be anything. So what you have to do? We have to install that in this particular mission, right? If you install that mission, then that operating system related issue will be fixed. So that is called the patch. Okay. Any other questions you have? So this is how you list images. Ashish, you are clear, or you have any follow-up questions? Just want to make sure that you don't get confused between virtualization and then containerization.
No, I got the idea.
Yeah, good. Because you are from the virtualization technology, right? So did you work on virtualization, Ashish?
Yes, actually, like it's infrastructure, so I have to work on all those things like
Okay.
Nash and all those things.
That's the reason I'm very much particular about you, because when you work there, when you know some technology, same when we know one technology, when we are learning other technology, we try to analyze the same thing, right? That we know. So you are trying to understand what you have done, what's happening. I mean, you're trying to understand what you know and how that happens in container. Correct?
Yes.
So that's the reason I'm asking you, do you have any confusion? Okay.
No, I got the point. Yeah.
See, for example, Git, okay? You know how Git works. When you when you are learning, other source code management tool, whatever you know in Git, you want to check, right? Okay, same thing, is happening. Same thing is available there. If it is available, is it working the same way in other tool? So that's what we do, everybody. So, and in that process, it's very, common that we get confused if you don't understand things properly. Okay. So Docker images, right? Fine. That's how we list the images. As we know, first time when you execute docker run -it command, right? Ubuntu /bin/bash, it downloads the image in our host, correct? And where it stores the image? Tell me. Where it stores the image? Images are stored here. That was a doubt, and then I think I already explained this to you long back itself. So images are stored here. Var lib docker. Okay. Here. Var lib docker is Docker's backend folder. Think that way. You have installed Docker in this mission, right? You have installed Docker in this mission. Docker stores everything in this directory. Docker stores everything in this directory. For example, image is downloaded. It stores the image here. You want to know where the image is? Image, it stores here, okay? Image, overlay, image DB. Don't try to remember. That's okay. We never have to work with this. Content, for example, SHA, LS. So this is the image. We have an image here in this mission, right? Docker images. Ubuntu. What is this image ID? F825. This is the image. So where images are stored? Images are stored in varlib Docker. Remember that. Varlib Docker. If you remember that, that is fine. I have also given the complete path for you, right? You can try to remember it later, not now. And the containers are stored here. In this mission, right? Assume that you are running 5 containers. All those 5 containers information is stored here. Let's see how many containers we have. Docker ps-a. How many containers we have? 6 containers we have. So it stores containers here. Containers, okay. See, you have 6, 790b, 7EC, BDB, 790b, 7E, 7E, BDB. So likewise, you have 6 containers, and then here you have 6 containers. So that's where it stores the containers information. So if you go to this, for example, 7, and that's a folder, okay. LS. See, that container information is storing like this in its own understandable way. We don't have to worry about that. So Docker stores, 1 second. Sorry. What I was explaining. Okay, so Docker stores everything here. Var lib Docker. It's like a Docker's backend containers, image, maybe network related things, maybe some dependencies, whatever. So that's where Docker stores all its content. So I have given that information here. Images live in this path, containers live in this path of your host.
We can
And,
see all these things in Docker Hub, right? With the image and image ID.
yes. You want to see Docker Hub? Did I show you Docker Hub so far? No, right?
No. In my organization, I think this I have idea, little bit.
Yeah. So when we execute Docker run command, anyway, I don't want to start new topic today, so let me show it to you. So Docker run -it and then Ubuntu /bin/bash. It downloads the image, right? So this is where images are present. So this is your Docker Hub. Just click on Docker Hub. Click on this link. This is your Docker Hub. I'm going to sign in. If you are a first-time user, you can sign up. Okay, sign up. Click on sign up. Give your email, username, and password, and then you can sign in. You can also sign in with your Google account. Sign in. This is my username, password. I'm logging into Docker Hub. It's like a GitHub. In GitHub, you have application code, right? In Docker Hub, we have images. So these are, whatever you see, these are all my images. Gamut cart image, Vitality image, my own images, custom images. If you want to search for any images, you can search here. Search Docker Hub. Click on that. I want to search for Ubuntu, say for example, Ubuntu. See, there is Ubuntu here. Click on this. So Ubuntu has multiple versions. Ubuntu 20.04, 22 you have 23, 24.10 and so on. So if you want a container with the 22 operating system, you can say docker run -it ubuntu :22. Here you can give the version. I'll explain this later to you. 20 dot. So this is where your images are stored, and then from here only it downloads the image. CentOS. Okay. So likewise, you have images for, you have a lot of images. I'll explain more about this later. Thing that you have not seen Docker Hub so far. Okay, so I wanted to actually start this topic called building your own image. Anyway, we'll take this in next class. You can start the class today. Any questions here? Any questions for me today?
Sir, in like Docker Hub, like do we have only public images or we can also push private images?
We can push private images. Like in GitHub, we have public repository, private repository, right? In GitHub,
Yes.
we have public repository, private repository. In Docker Hub also, we have public repository, private repository. Ubuntu and all these things are in public repository. And we store our images in private repositories. We can store that.
Okay, sir. So for just for my clarity only, sir, like to Docker image to create, we have to do the changes on the container and we have to stop it. And we can do some commands to take the image out of that container, right? Is
Come
that
again.
we do?
Come again.
I mean, like to create a custom image, like we have to create a container from a public image. Then we have to do the changes. Then afterwards, we have to stop that container and do some commands to get the image out of that container. Is that the way to be?
Yeah, one way. There are two ways to create the image. So by writing the code, you can create the image. Or if you have one container, you can create an image from that container. For example, you take a plain Ubuntu container, as you said, you install 20 things and convert that container as image, and then you can create any number of containers out of that image. So there are two ways. Whatever
Okay,
you
sir.
spend, that's one way. You're right.
Okay, sir. So for like a monitoring purpose and all, let's say we are having like 10, 15 containers in a host. Then for monitoring these 10, 15 containers, can we use Kubernetes or like other third-party tools like Datadog and all?
Kubernetes. In fact,
Okay.
we run these containers inside the Kubernetes.
Okay, sir.
That means
So is there any
Kubernetes, if you run these containers inside the Kubernetes, right, you get a lot of advantages. As you said, monitoring, scale up, scale down, self-healing, rollback, and then zero downtime release. So all those things you can do very easily if you have your containers running in Kubernetes.
Okay, sir.
Okay, it's
Yeah,
like we are learning, we're still learning the containers part, creating the image and then how you create the containers. So once you understand containers, creating the containers from the image and creating the images, then we will be actually running these containers in Kubernetes too. That's next.
Yeah, I have one question. Suppose there is a real time, we have a pre-production server.
Okay.
And we want to create a push image of that pre-production server to like Docker Hub.
No, see, in that case, if you have, when it's a pre-production server, it has to be container. From VM, you cannot create Docker image. Docker image can be created only from a container. So if the pre-production machine is a container, you can create a VM. Sorry, if the pre-production machine is a container, you can create an image and then yes, we push that image to the Docker Hub.
Okay. So suppose like in a way we can do in a way like suppose we have a real-time pre-production server and
Which is
we
a VM
copy
or
the
container?
it's a VM. Actually, it's a VM,
It's a
and
VM.
we
Okay.
created a copy of that VM. And after that, we installed Docker over that pre-production server. So now can we create an image and push to Docker Hub?
No, no. You have to follow the same steps. So you have a VM, right? Pre-production VM you were calling, correct?
Yeah.
So this is a VM, say, for example, pre-prod VM. Okay. Now next.
Suppose it's a pre-production VM, and now we want to create an image of this VM.
Okay. So that means you want to create whatever XUE, something is right? X.
Yes.
what-
No, not XV. I am saying I'm talking about like Docker, Docker containerization. If like using like after installing to Docker in this VM, we can create an image and push
No,
to
no. Say for example, you have a pre-prod VM, you install Docker here. Okay.
yeah.
Using Docker, you cannot create another VM, or you cannot create the image. Okay. So Docker is not the tool which converts virtual machine to the containers. No. So
Okay.
it's a container to container. So I
So
understand.
suppose if I
You
want
have what you are expecting, right? You have Docker. Okay, this is a pre-prod machine. You have a lot of things. Using the Docker, you want to create the image, correct?
yes,
So
yes,
that you can
yes,
create multiple VMs out of it. No.
yes, correct.
Docker cannot convert virtual machine to the containers. No.
No, I'm not talking about like creating a multiple VM. Like I want to create a multiple like containerization with this.
Which which is equal to this which is equal to this particular pre-prod VM.
Yes, like I have a clear thing. Like I want a lot of container image like using image of this pre-production. I want to create a lot of like containers.
No. So you cannot, that's what I'm doing. So you have a VM, right? Basically, you want to create containers from
Yes,
this, with the stuff, assume the 10 tools are installed here. So you
yes,
want to
yes,
create containers which automatically get 10 tools, correct? No.
yes, correct.
No, that's it is equal to, you are converting, virtualization to the container, right? This is not the tool. Docker cannot do this. If you want to do this, there is a way. As I said, here, let me be clear on that. We have tried the Docker file, okay, code. So in this code, we say, I want this, I want this, I want this. So you execute this particular Docker file, it will create the image. Okay, so that's how we create the image. Or you have a container, say for example, you can convert the container as image, but it has to be container. These are the two ways you have. So this is not possible.
With VM, we cannot do that one.
No, with VM, we cannot create the image. It has to be a container.
Okay.
From image, you can create the container. From container, you can create the image. So it's not a, what do you call that term? There is some word I just unable to, get it. You cannot basically, modify the virtualization to the containers. This is not the tool.
Okay, so suppose if I want the same like pre-production server is there, so I want the same thing for image thing. So I need to install everything again to that to that
Container.
content
Yes.
container?
Yes. So you have 10 tools here, okay? Some configurations.
Yes.
So you have to create a container, you have to install 10 tools, and then create the image. From this image, you can create millions of containers, one thing. Otherwise, you have to write the Docker file, okay? Docker file. So you have to know, okay, right, what 10 tools are installed. So in the Docker file, you write the code. I want Ubuntu, I want JDK, I want Tomcat, I want blah, 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 blah. So you have to write this Docker file and then create the image. This is the preferred way.
Okay.
So if you cannot just, convert this as a container or image, no.
Okay.
So suppose like I'm joining an organization where they are running their application on VMs, and let's say their requirement is to migrate the application from VM to containers. So can we achieve that?
Yes, you have to, as I said, you first need to understand, okay, what is present in that VM, in that application server, and then you have to write the Docker file. From the
Okay.
Docker file, you create the image. From image, you can create the containers. You should write the Docker file. It's not that you just transform this to something else. No.
Okay.
And
Perfect.
that information comes from the development team and testing team and so on. So if somebody tells you, this is the thing, okay? Somebody will tell us, okay, I want this in my mission. So we write this particular file and then we create the image. And from the image, we create the container. So you have, you're living in virtualization technology. If you want to containerize that application, you have to write the image. You have to build the image by writing this code.
So, sir, like this Docker file includes the dependencies like the JDK which we have for Tomcat server, right? Those kind of dependency we have to
Whatever
write inside.
dependencies, prerequisites we need, we have to mention all those things in Docker file. So it will
Okay.
create the image.
Okay, so you mean to
Okay,
say create a new server, so and installing all those things which is required and then creating an image.
Yes, one way is this. Okay, you create a new container, plain container, install all these things, and then create the image. Second way is writing the code. There are two ways to create the image, Ashish. This is your
Okay.
virtualization kind of way, right? You have the pre-prod server, install everything in this container, you can create the image. Or you write the code. You write the code and then create the image. Two ways you have.
Okay, good. Okay, understood. So directly we cannot do those things.
No.
Okay.
Okay. Fine. So yeah, there are topics related to all this. So since you don't know those topics, a lot of questions, right? I could have passed your questions and told after few concepts you will get the clarity about all these things. But since people already have their existing knowledge, they get into confusion. So that's the reason I'm not postponed. I try to give the clarity. Other people, you'll get clarity on all these things. Don't worry. Okay. So let me save it. Maybe it is helpful. Okay, fine. Thank you. Good night. And one second. Diwali. Last batch people were asking about Diwali holidays. 31st is the Diwali, right? And Wednesday, mostly people will be traveling. So I'll try to take the class on Monday, Tuesday, Wednesday, Thursday, Friday, holidays. Wednesday, Thursday, Friday. You can plan accordingly. Monday, I'll try to take the class, Monday and Tuesday. Thank you, everybody. Good night.
Thank
Thank you,
you.
sir. Good night.
Bye-bye.
Thank you.
Thank you, sir.
Thank you.